Hello everyone, welcome to the Click Physics 1 course, Lesson 4, Measurement, Unit Conversion, and Measuring Instruments. By the end of this lesson, we will be able to convert between common SI units correctly, convert units of length, area, volume, mass, and time, explain what a light year measures, and identify common scientific measuring instruments and their uses. Well, there is a question. First, why do we convert units? Well, different situations require different units for the same physical quantity. For example, the length of a pencil is better measured in centimeters, while the distance between two cities is measured in kilometers. Sometimes a question gives a value in one unit, but the formula requires another. In that case, we must convert the unit before solving the problem. Here are a few simple examples. Like 800 centimeters equal 8 meters. 5 meters equals 500 centimeters. And 2 kilometers equals 2,000 meters. The key idea here is to use the correct conversion factor. Conversion changes the unit, but it never changes the actual physical quantity. Converting area and volume. Area and volume conversions are a little different from length conversions. Since area has two dimensions, we square the conversion factor. For example, 1 meter equals 100 centimeters. So 1 square meter equals 100 square centimeters, or as written here, 10,000 square centimeters. Volume has three dimensions, so we cube the conversion factor. That means 1 cubic meter equals 1 million cubic centimeters. A common mistake here is forgetting to square or cube the conversion factor, so always try to pay attention to whether you're converting length, area, or volume. Common unit conversions. Well, there are some basic conversions that every physics student should know. For length, 1 kilometer equals 1,000 meters. 1 meter equals 100 centimeters. 1 centimeter equals 10 millimeters. For time, 1 minute equals 60 seconds. 1 hour equals 60 minutes. 1 day equals 24 hours. And for mass, 1 ton equals 1,000 kilograms, and 1 kilogram equals 1,000 grams. And keep in mind that these are some of the most frequently used conversions in physics problems, so it's very helpful to memorize them all. English and metric units. There are different systems of measurement used around the world. The most common system in science is the International System of Units, or SI system, also known as the metric system. However, some countries such as the United States still use English units in everyday life. Some common English unit conversions are 1 inch equals 2.54 centimeters, 1 foot equals 0.3048 meters, and 1 mile is approximately 1,609 meters. And although you may see English units in some questions, scientific calculations are usually performed using SI units. Light year. Despite its name, a light year is not a unit of time. It is actually a unit of distance. And how is that? A light year is the distance that light travels in 1 year. Since light travels incredibly fast, about 300 million meters every second, 1 light year is approximately 9.46 times 10 to the power of 12 kilometers. And astronomers use light years because distances in space are far too large to express conveniently in kilometers. For example, instead of saying trillions of kilometers, we simply say that a star is 4 light years away. Measuring instruments. In physics, every physical quantity has a suitable measurement instrument. Some common examples are a ruler, which measures length, a micrometer, which is used for measuring very small thickness, such as the thickness of a sheet of paper, a vernier caliper, which measures the inside diameter, outside diameter, and depth of objects with high precision, a thermometer used to measure temperature, and a stopwatch, which measures short intervals of time. And choosing the correct measuring instrument helps us obtain more accurate results. Well, many scientific instruments are designed to measure some very specific physical quantities, and we have more of those measuring instruments in here. For example, a barometer measures atmospheric pressure. A manometer measures the pressure of gases inside a closed container, which we call gas pressure. An ammeter measures electric current. A voltmeter measures electric potential difference, which we call voltage also. An ohmmeter measures electrical resistance. A multimeter combines all three functions, allowing us to measure current, voltage, and resistance. Are commonly used in laboratories and electrical experiments. Other scientific instruments. Well, let's look at a few more measuring instruments. A dynamometer measures force or weight. A calorimeter measures heat energy transformed during physical or chemical process. An anemometer measures wind speed. A spirometer measures lung capacity and breathing performance, and an electroscope detects the presence of electric charge. Although you don't need to memorize every instrument immediately, it's important to recognize their names and know what each one measures. And we're done here. Thank you for watching, and I'll see you in the next lesson.